and I'm looking for a job in New York if you know anyone hiring. I know a lot of people hiring though. I want to find someone who wants to give me a visa as well, and that's the hard part. So I'm actually starting up by myself in New York soon, and then it'll be easier to find clients. I also have a message on LinkedIn apparently. So what we're going to do today is we're going to work with this great app that I created. Let's go out to the front page. I created a very, very quick, awesome book database app, and it's awesome because it says so there, awesome. And so we're going to do three things. We're going to do a brief introduction to React Suspense, what it is and how it works and why it works, not so much why. We're also going to talk about GraphQL, a rough introduction to GraphQL and how it does the things it does and why it's a good idea. And finally, we're going to talk about AWS AppSync, so that's Amazon Web Services service called AppSync. And it's basically a GraphQL backend without a need to code or to code very much. So it's super simple to set up and it works very well. So that's the plan. And I'm only at 51% power, so I hope we can make it. So we have this app. It's a very simple app. It has a front page you see here. It has all of the data right now is static, so it has a create author page, and if you press this, it'll go to the show author page, Stephen King, and information about him. It also has a list authors page, and you can go and see the author, and then you can see a book, and has a create book page where you select the author that the book is made by. So that's the very simple app, and it has very simple data structure, a few things that you need to create. If you type something here, nothing happens because it's not connected to anything. And it just has a sleep 1,000 milliseconds, and then it moves to another page. So that's what we have as a front end, and it's just, I'm not a designer, so this is just Material UI, and took a few hours to set up. So it's very simple, just with standard components. So the first thing we're going to talk about is Suspense. So Suspense, does everyone know React? Who doesn't know React? Does anyone not know React? All right, so you're going to be a little bit confused because I'm not going to introduce React. But React is a framework for building web apps like this. So if you don't know React, this is going to be a little confusing, the React part at least, but maybe you can enjoy the other parts of it. So I have created this, as you see over here. So here is a not very interesting index. So this is my home. This is also not very interesting, but we have my app out here. So this is my app. It has my toolbar, and it has the routes for the different pages that we have down here. So it has a create author create page, author list, author show, a create book, show book. So those are the sub pages that we have. So the first thing we're going to do is we're going to wrap this in React Suspense. So what Suspense does is that it will detect if any of these pages or any of these components below this component that we're looking at right now will throw some kind of error, which is not an actual error. It's just that they're saying I'm not completely ready to load yet. And now nothing happens because we still have the very same page and it works just as well. So, but if any of our components they throw, sorry, yes. On the editor. We can bump it up further, sure. We good?
Can you change the background?
I don't know. Can I? All right, we're doing something. Someone is doing something. Okay, so we've wrapped our main section of the app in a React Suspense. So it will detect if any of the components in here or any components inside those will throw a promise. So if they throw a promise, it means that the component says, I'm not ready to render yet, but when this promise resolves, I promise you that I will be ready to render. Or maybe it will throw another promise and then it'll wait for that one as well. All right, now, there we go, nice. Now we probably ruined the video. All right, so let's try that out. So currently we're looking at the create author page. So let's, in our create author page, in the render function, throw a promise. Throw new promise of just a dummy function. So this promise never resolves, that doesn't really matter, because this will now say, well, this threw something, so we'll just show the loader. If this promise resolved, then it would hide the loader again, show the real tree, show the same page. it would throw a new promise, and we would go back in an infinite loop, and that would be very annoying. But that's how it works. So the promise has to know that it has resolved. So the trick is, so what is this used for currently? Currently it's used only for lazy loading components. That's more or less what it's set up for. It will also be used for loading resources, and we'll hack it to do that today. But it's used for lazy loading other components. That means that you try to render a page. It says I need to render this sub component, but it's not loaded yet, so it will throw a promise, and then it will keep loading that in the background. It will remember that it has loaded that, so second time around it comes back. Then it will say, okay, now I will try to render this component. I already have it in my cache, and then it will show it. So we need to do the same thing just with our data. So we need to have a cache of the data. Because if we just keep doing this, the component will just keep instantiating, try to load the data, and then see, oh, I don't have the data, so I'll try to load it, and it'll show a loader, and then the whole component will be torn down, set up anew, and it'll keep loading. So we need to cache whatever data that comes in. We'll get back to that. So that's how this works. Let's remove this stupid promise again. All right, we're back. It's working. Okay, next thing we'll do is we'll go to Amazon. You can see here I'm logged in. Everything is good. We'll visit AppSync, which is the service we're going to use. And it's loading. So that's interesting. Someone threw a promise somewhere. I promise you, wasn't me. All right, let's switch to another Wi-Fi. Am I here? Oh, that's not me. I'm P20. Okay, that's fun. Try it again. Where'd it go? We're in somehow. There we go. So let's create a new API. We create from scratch. There's also a wizard you can go through, but let's create a new one from scratch. It'll be called my awesome book database. Okay, so in this database, we're going to have two types of objects. We're going to have authors and we're going to have books. And authors will have books and books will have an author. So it's a one-to-many relationship between those objects. So let's create a resource. The first one is we'll create an author. Author will have a name and, of course, information everyone needs to know, their favorite animal. And that's it. This is a display of the GraphQL internal language that will be auto-created for us. So it will automatically create a query for getting and listing authors. It will create mutations for creating, updating, and deleting authors. Also create some things for subscriptions so you can listen to when something happens. It'll also create some filters so you can ask for all authors where the title matches something, etc. So it'll make those things for us automatically in the background, and it'll take a short while. And the second thing we need to create the book model. And the book will have a reference to the author of the book, and that'll just go by ID. So when we're done here, yes, there we go. Then we'll go create a book. A book will have a title, so that's good. It'll also have a page count. Let's say that's an integer. The exclamation point means that it's a required attribute. We won't bother much with that. Let's just put that in there. It'll also have an author ID. So we need to look up books by author ID at some point later. So we need to now, we could also do that later, of course, create an index on the author ID. So we add that down here. Author ID, index, primary key, author ID. All right, we're good to go. Create that one as well. So now we've set that up. So now this API works, it's live, it's functioning. You have all these things. If you know the address for the API endpoint and you know the API key, you can actually use this. You can create authors and you can create books, etc. But they're not linked yet. You cannot say I want this author and all his books because there's no link between them yet. So let's first of all, it's still loading. All right. Creating the index probably takes a while. So first of all, the book is going to need to have a reference to the author. And when you have an author, you need to have a reference to the books of that author. So let's do that by adding a books property to the author, which is a book connection. A book connection is a list of books. It's actually a paginatable list of books. Paginable? I don't know what it's called. So it's a list of books where you can ask for pages in it. And otherwise for the book, we don't need to know the author ID of a book. rather have the author, which is of type author, of course. Save the schema. All right, so the next thing we do is we have to hook up these new attributes. So for the book, when we have to find an author for a book, we will of course look in the author table, and we will say get item by ID, and we'll just look at the source.author_id. Source, author ID. Because the source, the current thing we have is a book, and we are looking for the author of that book. So we're just doing that. That's it. It works. Let's add the other resolver. So the other way around, the author has books. So we have to look in the book table. This time around, we're not getting one item, we're getting more items. So we're doing a simple query. Remember to add that we're using another index, because otherwise it will require us to ask for the ID. So we're using the author ID index. So we're looking for books where the author ID is set to the source.id, because the source, again, is this author that we have right now. All right, that's it. We have a backend. Everything is working. So let's copy paste some of these things here. We have the API URL here. Let's put that into our GraphQL here. So we paste that in there. And if you're really quick and you wrote these information down, you can go in and put all sorts of profanities in there and annoy me. All right, so what I have here is a very simple wrapper for the built-in API. So this is part of something called Amplify. Amplify is made by AWS, which is a client-side library for many different AWS services. So if you use Cognito, which is a way of authenticating users, it has something to do with that. You can also use a GraphQL, for instance. You can also use Lambdas directly. You can also upload to S3 and get things from S3 easily through that. So you don't have to go through the HTTP API. You can go through their ready-made API. It can also actually generate stock code for the GraphQL endpoints that we just created. But we're going to write the raw GraphQL endpoints. All right. So what we have here is something that can throw a promise, because API GraphQL will throw a promise. So we have that thing here. So we're going to need that in our create author. So when we create an author, we are not going to sleep. We're going to invoke our GraphQL, which is from invoke GraphQL. And instead of sleep, we are just going to invoke GraphQL. We're doing that with a mutation. And then we're going to another page, and the result will be structured as. So it has a data object which has a create author, which has an ID. All right, so that's where we get the data out. So the mutation that we're going to create. Now it comes the GraphQL part of it. So here, we're going to create a mutation. Let's just call it M. This is just an internal name that you use, so it doesn't really matter what it's called. We're going to invoke the create author endpoint. We're going to give it input. This has to be structured as JSON. If you want to know exactly what it looks like, you can go to your schema, scroll down to find the create author input. It has a name and an animal. All right, so that's good. So it has a name. And here we are going to put in our name. It comes from our state. So this .data.name, state.data.name. And it also has an animal, which also comes from our state. So the same way around, this .state.data.animal. All right, so that's it. After that, we're going to ask what do we want back when this succeeds. All right, we just want the ID back of the new author that we've created. And if things go well, this should work right now. So we're creating this mutation here. It's not doesn't look super nice, but it should probably work. Let's see what happens. I'll go here. I'll create an author. And let's see what happens in network while we're doing it. All right, let's make this a bit bigger. Here, there we go. So let's add Brad Easton Ellis, everyone's favorite author. All right, let's type that one. And his favorite animal is a dog. Pretty boring. Create. And we see here that we send our query down here. And in the preview, we get back a data object with a create author object with our ID. So we actually have that right now. You can also see it up in the URL. It has the author ID. This page, of course, is just using generic data. So this doesn't work yet. But we have now actually created it. If we went to AppSync, went to DynamoDB, which is the underlying table, we could actually see the data in there right now. So that would be pretty fun. But we're not doing that. So the next thing we're going to do is we're going to list our authors. All right, one sec. So, to list the authors. Okay, so we have to do another query. So let's go to the list authors page. This time, we are also going to import the promise throwing invoke GraphQL, but we are going to make sure that our component suspends whenever this happens. So we're also going to invoke something I'll call a cache suspender. I consider wearing suspenders today. So this will be our cache suspender. There you go. So instead of just having this hard-coded array of authors, we're instead going to get it from GraphQL. So our result will be going through our cache suspender. It'll first take the promise throwing function, so that will be our invoke GraphQL, and then it'll take the arguments. So it'll just take a query. And we can actually make that a hard-coded, that a constant, because the query is just a constant thing. So our query will be, so there'll be a query queue. And again, you can go look at what your options are, but we'll just go list authors. This has an items, and each of those, they have an ID, and they have a name, and they have an animal, and they also, of course, have the array of books. And for each book, you just want the ID. We just want to know how many there are. Oh, that's actually inside items as well. They have an ID. All right, so there we go. That's our query. So the cache suspender, we haven't implemented that yet. So what it's supposed to do is, it's supposed to, we can just look at it. We just have it right here. So we're going to have an internal cache of already created promises earlier. So this is more or less the idea it does. So it will create a cache key that it can then look up again. So if it comes back with the same promise throwing function with the same arguments, it'll say, well, I already know your answer. So I already have it in here. Because if we did not do that, it will just keep throwing a new promise every time. So it needs to know that when it comes back around second time, I already have the answer. We'll go back to cache invalidation later. So let's create a cache key. So the cache key will just be our get cache key function for an object, which is just something that we can serialize. All right, so the arguments for this one as well. So if our cache key is already in our cache, cache key, in cache, then we'll do something. If not, we'll create a new item. So let's create a new item, cache item. It has a result, which is null from the start, and it has a promise, which is also not set yet. Promise, which is also null. Promise, null. Whoa, that went wrong. All right, there we go. So let's create the promise, and we have to, of course, intercept the promise and save the result. So let's say our cache item dot promise is our promise throwing function. Let's apply that with null and our arguments, and we then have to then it to save the result. So we have a result from this, which is something, and we will save that on our cache item dot result equal to this result. So from this point on, we don't really know what it is. It's just something that we can return later. We'll add that to our cache. So cache key is our cache item. All right, and then we'll throw the promise. So we'll throw our cache item dot promise. Okay, so if we first time around, this will happen and it'll throw the promise, which will then at some point later resolve with the result from the backend. So that's good. But if we come around second time, we already have the key in our cache. Then we need to first find the cached item. So we look it up in our cache. Then if it has a result, if cached has a result, we'll just return that. If it doesn't have a result, or there could also be, of course, some error handling here, we're not doing that at all. So if it doesn't have a result, we'll just throw the promise again. Because you might come back to a page, for some reason you might navigate around and you come back to the same page and it hasn't resolved yet. We don't want to create a new promise, we'll just throw the old promise once again. All right, and we've got to do something somewhere else because here we get a, not here, in list authors. So here we get a response back and then we have to find the authors, and authors are inside this response as res.data.listAuthors.items. So let's see if it works. It does. Fantastic. So we can now list authors. That's pretty nice. So, if you look and I go to create author and then I go back to list authors, there's no delay because it already has this result. But what if I go to create authors, create a new author, and then go back to list authors? It would keep the same thing because we have to invalidate this page. And we have to invalidate it because imagine that this component might re-render because of some internal state. So we can't just, first time you get the result back, we can't just delete it from the cache because this page might re-render several times. Could of course save that in state somehow, but still, it's probably a good idea to keep it in the cache until we say we don't need it anymore. So let's create something so we can easily kill our cache items. So we'll export a new function here to kill our cache. It will also take the same arguments, so it'll take a promiser, and it'll take our arguments, and it will then delete from our cache a get cache key based on the same arguments again, so promise.args. So now we can kill our cache, and I really don't have a license for this. And over here in our list authors, we'll say component will unmount. And then we will kill our cache with the same arguments, which is invoke GraphQL and our query. So, and we also need to import that one. So we'll here import default as this one, and we'll also import our kill cache. All right, so I just did, didn't I? Did I forget something? Export kill cache. No, I think we're good. Did I forget to save this one? Kill cache. Export const kill cache. Can anyone see any errors here? Shout it. You are absolutely correct. Well done. You win. All right. It's of course from this one here. So it's from the wrong file. So here we'll just have our invoke GraphQL. There we go. Whoops, typo, there. And now, if we reload the page, you'll see that it loads first time around and then it'll show the page. If we navigate away, it has cleared the cache. So next time we come back to the page, it will not have it in the cache. You'll show the loader and then the promise will resolve again. We could of course also use the same cache killing thing and read it again if you had something drag to refresh or something similar. So this is basically it. And we don't have so much time, but I can also, of course, implement the other things. So for create book, you would do the same thing. First, you would need to load a list of all the authors, and then you would need to also then create book with those values again. And the same thing for the subpages. So for a show author, you would need to load the information about the author. So the cool thing is that in this query, for instance, if we also wanted the title of the book, we'd just add that. And then we can have the title. And for instance, if we also wanted to know, well, what is the author of this book? Well, I would like to know that. And then we can add that here. Because it's GraphQL, we don't need to change anything on the back end. We can just keep doing that. Well, I like to know the books by this author. Right? And we can do this stupid iterative thing there. We can keep going because all of this is connected in the backend. So it knows how these objects belong together and it'll just return them. So if some designer comes along and says, hey, I'd like to also show the page count on this page here. You don't need to talk to the backend guys because it's already created. You just add it here. Well, I also need the backend, the page count for this one because you've already created all this. So things we haven't covered. Well, there's no testing in here, so we haven't covered that. There's also no security in here because so this is an open API. Everyone with the API key can do anything in it. So if I made this web app public, then everyone could just go in and put anything in there or delete everything. So if you wanted to do that, we can actually add Cognito on top of this. It had another half hour, and I don't think it would take more. I could actually add Cognito on top of this, so there would be a login and sign up. And then I could only see the items created by me, or I could only delete items created by me, but everyone could see all items or something like that. So whatever you would have as your authentication scheme, you could easily implement that because it's very simple to do as well. Because Amazon has all these different services that work together pretty well. Yeah, so I think that's about it. Any questions?